Class 11, Gravitation, Recapitulation. This particular topic you had already gone through in class 9 also. Basic idea in 9. Recapitulation, what is the meaning of 9 also you had gone through it. The force of gravitation, say that two objects are there. And here the center of mass of these two objects. R is the distance between them. Here mass of this object is m and this is of small m. Then the force of gravitation is directly proportional to the capital M, small m, this is a capital M, by R square. F is equal to capital G m by R square. This is a capital G, universal gravitation constant. What is that? Universal gravitational constant. And its value discovered by Cavendish, 6.67 into 10 to the power minus 11 Newton meter square per kg square. The fundamental. So the force of gravitation is the central attractive force which acts between any two material object in the universe. Second part is that acceleration due to gravity. Or before coming on to the acceleration due to gravity, this is the first recapitulation. Second part is that gravity. Gravity is the another name. Gravity means what? If the two objects which are going to be attracted, see here one object, here another object. Object number 1, object number 2. If either of the two objects is one is Earth, say the second object is Earth, then the force between this object and this object is known as the gravity. So gravity is the same thing, force of gravitation, but one of the object becomes Earth. Then this same force of gravitation is known as the gravity. Third point of the recapitulation is that acceleration due to gravity. Acceleration due to gravity. All the things you had already gone through in class 9, but here the recapitulation. The acceleration produced in a freely falling object under the gravitational pull of the Earth is known as the acceleration due to gravity. And मीन्स इसको हम बोल सकते हैं कोई ऑब्जेक्ट अर्थ की ओर जिस एक्सेलरेशन से गिर रहा है, जो एक्सेलरेशन है उसको बोलेंगे. एंड दैट स्मॉल जी इज वी नो कैपिटल जी एम बाई आर स्क्वायर. वेरी इंपॉर्टेंट रिलेशन. कैपिटल जी एक्सेलरेशन ड्यू टू ग्रेविटी, कैपिटल जी universal gravitation constant. M is not the mass of the falling object but rather mass of the bigger or the planet. M is the mass of the planet. M is the mass of planet which we are talking about here. Means which planet we are talking about? Earth. And R is the radius of the Earth. If the object is on the surface of the Earth, like that. Right? And R is what? R is the radius of the Earth. Now, in class 11, we are going to discuss that how G is going to vary. How G varies, that we are going to discuss. But before that, recapitulation continue. Another point, and this is the third point, this is the fourth point. Another point of the recapitulation part is that importance of gravitational force. What are the importance or inferences? Number one, it is independent. These points are important. Independent of intervening medium. Intervening medium. Number two, it obeys third law of Newton's motion. Number three, third point, it strictly holds for the point object. Point objects or point masses. Number four, it is the central force. It is central force means this particular object is there, here the another object. So the line joining these two objects, the midpoint is the central point. So the force by which this is attracted by this and the force by which this second object is attracted is always tends to the central point. That is the meaning of central force. Number five, it is a conservative force. Conservative force. And the last point is that this is a gravitational force between two bodies. See it, two bodies is independent of presence of other bodies. Means if the gravitation force is there between the two objects and some more objects are here, but we are talking about this m1 and m2, and if we are going to find out the force of gravitation between these two, so these two objects, surrounding objects are it does not play any role in between this, but rather we are going to use it later on with the help of principle of superposition. So these are the main points which you have to remember. Another very important point of this gravitation, especially in class 11 for 11, the very important concept. Try to understand this concept. The concept is known as the shell theorem. However, it is not in the syllabus, but you have to remember important point. Shell theorem is the gravitational force. What is it? Gravitational force on a point mass due to a spherical shell or solid sphere. Now what is it? Here, first point, it is that if you are having the spherical shell, first the spherical shell means just like a tennis ball or simple ball. Here hollow. spherical shell is there, just like this ball, hollow ball. So if you are having the spherical shell and from the center one point mass is there, which is at r distance here, one point mass. What is that point mass? Say this mass is m, and the mass of this shell is capital M. This mass is capital M, like that. And this is the point object, point mass. So here radius of this particular shell I have taken capital R. Then the force between these two, this spherical shell and the point mass, is capital G M by R square. Here the condition is up to this condition. Means shell attracts the point mass as if the entire mass of the shell were concentrated at its center. Maybe the hollow or the solid sphere. Here we have taken the solid spherical shell. You can take the solid sphere also. In both the cases, दोनों केस में ऐसा महसूस होगा कि इसका भी मास और इसका मास वो बिल्कुल सेम है. यहाँ पर सेम मीन्स m, कैपिटल M, स्मॉल m by r square. ये r in fact it is small r square, because distance between the center of this spherical shell and the point mass is small r. So that is your first part. Now the same thing, if the object is solid sphere, then also it has the same. If the solid solid sphere is there and point mass m is what point mass, then also, and the same thing r, then also the force is same, force of gravitation G, the mass of this solid one is m by r square. R must be greater than or is equal to capital R. Now this is the first case. Now the point is, if the object, now second case, if the point mass lies inside a uniform spherical shell, the gravitational force on the point mass is 0. That's an interesting case. This is the spherical shell. Yes, I have taken a spherical shell like that, and the point mass is inside the radius r. Now point mass is here inside, and the whole mass of the spherical shell is this, and the distance between the center of the sphere means spherical shell and the point mass is small r. Then the force is equal to 0. Force between this particular spherical shell and the point mass, force is equal to 0. Now tell me the reason. What should be the reason? The reason is that here the spherical shell is made up of the small pieces. So this particular one force is acting between this one small piece onto this mass. Here also, similarly here, means all the forces are going to be cancelled or neutralized. That's why the force is 0. In short, अगर हम बोल सकते हैं कि यहाँ पर एक कोई मान लेते हैं मेटल का केज है, एक पिंजड़ा है, उसके अंदर कोई एक एक बर्ड है या कुछ भी है, तो कोई पूछेगा कि ये मेटल केज है वो और बर्ड के बीच का फोर्स कितना होगा, तो 0. दैट इज द ग्रेविटेशनल शील्डिंग. दिस इज ऑल्सो नोन एज just like the electrostatic shielding which we have discussed earlier. Now, electrostatic shielding in class 12 electrostatic. Now, if this particular spherical shell is not there, if the complete means a solid sphere is there, that's also interesting. अगर ये कंप्लीट शेल है, सॉलिड स्फीयर है जिसका मास कैपिटल M है और एक पॉइंट मास यहाँ पर हम लेके आए हैं इसके अंदर ही जो R डिस्टेंस पर है और इसका रेडियस तो वही कैपिटल R. तब हमको क्या करना होगा यहाँ पर, तब पूछा है कि इसमें फोर्स कितना लगेगा. तो हम पहले ये जो मास है इसको हम एनसर्कल करेंगे. ये मास कितना दूर तक है जहाँ पर कि पॉइंट मास हम लेके आए, इसका मास हम मान लेते हैं mr. किसका मास, ये वाले डॉट 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 लाइन से जो स्फीयर बना है उसका मास mr. ठीक, तो यहाँ पर फोर्स experienced onto the point object is equal to g mass of that cutted portion, this one mr, into small m by r square. Important. Now this is why important, because its application is there. Now we can write mr also in mr in terms of m. How we are going to use it, कैसे हम mr को, हम चाहते हैं mr को m के टर्म में रिप्रेजेंट करें. यहाँ पर हम क्या देख रहे हैं, दो सॉलिड स्फीयर है, एक बड़ा वाला जिसका मास m है, एक छोटा वाला जिसका मास mr है. तो यहाँ पर हम लोग वॉल्यूम में अगर हम इसको कंपेयर करते हैं तो वॉल्यूम हम जानते हैं, बड़ा का स्फीयर, बड़ा वाले का कितना होता है वॉल्यूम, कितना होता है वॉल्यूम ऑफ द स्फीयर ऑफ द बिगर वन, बिगर का मास m है तो उसका मास कितना हो जाएगा 4/3 पाई r³ माने r³. बड़ा वाला का इतना वॉल्यूम होता है और छोटा वाला का वॉल्यूम जिसका मास छोटा वाला का वॉल्यूम मतलब mr, उसका वॉल्यूम कितना हो जाएगा 4/3 पाई r³. तो हम लोग वॉल्यूम क्यों निकाल रहे हैं, क्योंकि हम लोग को ज़रूरत है मास निकालने के लिए. हम लोग को मालूम है कि डेंसिटी इज इक्वल टू मास बाई वॉल्यूम होता है. तो मास इज इक्वल टू, अगर डेंसिटी हम लोग लेकर चल रहे हैं, डेंसिटी तो सेम मटेरियल है, रो डेंसिटी है, तो m इज इक्वल टू वॉल्यूम इंटू डेंसिटी. तो फॉर बिगर स्फीयर, बड़ा स्फीयर के लिए अगर हम लोग लेकर चल रहे हैं मास ऑफ द बिगर वन, जिसको हम लोग रिप्रेजेंट कर रहे हैं कैपिटल M से ना, तो कैपिटल M से इज इक्वल टू कितना हो जाएगा, वॉल्यूम इसका 4/3 पाई r³ इंटू रो, एंड स्मॉलर स्फीयर का मास mr से रिप्रेजेंट किए हैं. तो ये हो जाएगा 4/3 पाई स्मॉल r³ इंटू रो. अब ये दोनों को अगर डिवाइड कर देंगे इसको तो मेरा कितना आ जाएगा, ये 4/3 पाई और रो कैंसिल हो जाएगा. क्या मेरा आएगा, यहाँ पर हम दिस डिवाइड बाय दिस कर रहे हैं तो ये हो जाएगा mr/m इज इक्वल टू r³ बाई r³. ये रिलेशन आया टू। अब यही वाला रिलेशन हम लोग यहाँ पर पुट करेंगे, ये वाले में। अब ये वाला में पुट कर देंगे तो कितना हो जाएगा यहाँ पर, तो वही इक्वेशन हो जाएगा कैपिटल जी एम आर की जगह हम लोग पुट कर रहे हैं एम आर क्यूब बाई आर कैपिटल आर क्यूब। ये एम आर की जगह क्या हो जाएगा, कैपिटल एम इंटू आर क्यूब बाई कैपिटल आर क्यूब इंटू एम बाई नीचे क्या था आर क्यूब, आर स्क्वायर था, ये फॉर्मूला में नीचे आर स्क्वायर था, तो ये फॉर्मूला आ गया। ये एक आर बच जाएगा, तो जी एम स्मॉल आर बाई कैपिटल आर क्यूब। ये इतना नेट फोर्स लग रहा है सॉलिड स्फीयर का केस में। किस केस में, ये वाला केस में। पॉइंट ऑब्जेक्ट यहाँ है, ये सॉलिड स्फीयर है, पॉइंट ऑब्जेक्ट इनसाइड द सॉलिड स्फीयर। ओके, दिस इज द शेल थ्योरम।